So am I audible? Is the slide visible to everyone?
Yes.
So welcome to the live interactive session number 11 on the subject mechanics of fiber reinforced polymer composite structure. Today I am going to discuss some sample problems which will be useful for solving assignment number 12. So let's start. So the first question is for a given load and dimension of a rectangular simply supported specially orthotropic symmetric laminate subjected to a transverse load QXY. The transverse deflection along Z will depend upon. So this equation, the first equation you can see here is the equation to find the transverse deflection along the Z direction of any laminate. Now here, it is mostly dependent on coefficients of the, whenever we consider a laminate, we talk about the ABBD matrix. So here you can see the coefficients that are used here of the A and D matrices as there is moment as there is moment and then there is load in the Z direction. And now in the question they said what will be the deflection when the laminate is orthotropic and symmetric. So now we know for a symmetric laminate the B matrix is equal to 0, and other than that A16, A26, D16 and D26 are also considered 0 for an orthotropic symmetric laminate. So considering this conditions, when we put the values of this coefficients as 0 in the above equation, this is the final equation we get. Now this final equation is for an orthotropic symmetric laminate. So here you can see the coefficients on which this equation depends are D11, D12, D66 and D2. So the answer of this question will be the option C, where it depends on these coefficients of the D matrix. Next question is, two glass epoxy laminates 0 plus 45 minus 45 90 symmetric and 90 0 minus 45 plus 45 symmetric have the same dimensions except the stocking sequence. If they are subjected to same transverse load, then transverse deflection of, the options are saying that these two laminates will it be having different transverse deflection or same or 0. So this is the equation which is used to find the transverse deflection of any laminate. Now here only they both are symmetric, so the B matrix will be 0. So only matrix which we have to consider here will be the D matrix. Now there, even though the angles which are used are similar for both of these laminates, but the positioning of those angles are different. And as I said, it will depend on the D matrix. So to find the value of the D matrix, this is the equation. Here you can see it depends on the reduced stiffness matrix and the position of the laminates and cube of the position of the laminates. As before, whenever we considered other like when we considered the A matrix, we only considered the thickness, but for B and D matrices we considered the position and the square and cube of the position, and according to that, so because of the cube root of the positions of the laminas in the stocking, it depends on the cube is taken. Because of that, it depends on where the particular angle stocking is present in that laminate. So here you can see as 0 is present first, then plus minus 45 and 90. So here the position, according to position, their cube root will be different. Hence the D matrix of this laminate will be different from that of this laminate. So here, because of difference in the stocking sequence, so their transverse deflection will also be different. So the first one will be the answer. Next question. In a rectangular A cross B 0 degree 90 degree symmetric graphite epoxy laminate, which of the following represents the simply supported boundary conditions along the edge x equal to A? As sir taught in the class that for a rectangular plate of dimension A cross B, the simply supported boundary condition we consider is that along x equal to 0 and A, W will be equal to 0 and Mx will be 0. Whereas along y equal to 0 and B, W will be equal to 0 and My will be equal to 0. So considering this, which is the simply supported boundary condition, we have to find from the options which is satisfying this condition. So here the first option which says that at x equal to A, W is equal to 0 and Mx equal to 0. So this one is the correct option. Now next question. In a rectangular A cross B 0 degree 90 degree symmetric graphite epoxy laminate plate, the buckling load is a function of the following options. Now the buckling load, the equation to find buckling load for a as you can see here 0 degree and 90 degree symmetric. As it is a symmetric laminate, so the B matrix will be equal to 0 and 0 and 90 is present, which means it is orthotropic. As there are no angled ones, so this will be an orthotropic laminate. So for orthotropic laminate, A16, A26, D16 and D26 will also be equal to 0. By considering, by taking this condition, the final equation we get for the buckling load of a orthotropic and symmetric laminate is this. So here you can see again the coefficients on which this equation depends are D11, D12, D66 and D22. So this will be the correct option, that the buckling load is the function of these coefficients of the D matrix. Next question. Two glass epoxy laminates 0 plus 45 minus 45 90 symmetric and 90 0 minus 45 plus 45 symmetric have the same dimensions except the stocking sequence. Then what will be the buckling load of these two stockings? So again, like the question previously we discussed, here also there is difference in the stocking sequence, and as for both, when we consider the equation of the buckling load, here again it depends on the coefficients of the B and D matrix. As it is symmetric, so the B matrix values coefficients will be equal to 0. So only we will consider the coefficients of the D matrix. And now to find the D matrix, we consider the cube root of the location of the laminas in the stockings. And as the position of different angles is different for both of these stockings, so their D matrix will also be different. Hence the buckling load will also be different. Next question. In a rectangular A cross B 0 90 degree symmetric graphite epoxy laminate plate, the natural frequency of transverse vibration depends on. So sir explained the derivation. I am not going on derivation. So the final equation we get for the natural frequency of transverse vibration is this, where you can see it depends on the D matrix coefficients D11, D12, D66 and D22. So the answer of this question will be option C. And again the same kind of question on stocking sequence, that two carbon epoxy laminates of 0 plus minus 45 90 symmetric and 90 0 plus minus plus 45 symmetric has same dimensions except the stocking sequence. Then what will be the natural frequency of transverse vibration? As again it depends on the D matrix, and I explained that the D matrix depends on the cube root of the positioning of the different laminas. So as the sequencing is different, so their D matrix will be different and their natural frequency of transverse vibration will also be different. Now next question is a numerical. That for a 3-ply 090 symmetric graphite epoxy laminate, the D matrix is given. Now the density of the graphite epoxy lamina is 1600 kg per meter cube and thickness of each lamina is 0.005 meter. The laminate is a rectangle with A equal to 0.75 meter and B is equal to 0.5 meter and is simply supported at all edges. So the first frequency, natural frequency of transverse vibration of the laminate is. So the equation to find the natural frequency of the transverse vibration of laminate is given by this equation. Here in the question they ask the first natural frequency of the transverse vibration. To find the first natural frequency, we consider the first fundamental modes, this m and n equal to 1. Now putting that value here, considering m and n equal to 1 and r here is the aspect ratio, that is a by b. So we are given the values of a by b. We already have the D matrix. From that we can get D11, D12, D66 and D22. We're putting the values here. Density is also given of the graphite epoxy lamina. We can find the first natural frequency of the transformation of the laminate from this equation. Then we put all the values here. So this is a very simple numerical. Any doubts? Any questions from the sample questions?
Ma'am, can you explain how to calculate the ABB matrix from the reduced transform stiffness matrix?
How to find the ABBD matrix? Okay.
Yes, ma'am. Uh,
Previous for that I have to find the equation. So for A mat, okay, I will show you from this PPT. Here you can only see the how to find the D matrix from this equation. Okay, so the Q is the reduced stiffness matrix. ZK and ZK minus is the position from the middle point of that laminate. So it is a symmetric. So from this point there will be, like, for one angle if there is 90, so ZK will be the thickness of that 9, is, you know, the thickness of that lamina. So here you will go know the value of ZK and ZK minus 1, which is above this. According to that, you will find the position ZK and ZK minus 1 of each laminas according to their thickness. So when you will stock them, you will find the ZK and ZK minus 1. Then Q is the reduced stiffness matrix. And this is the formula to find the D matrix. Similarly, there are formulas of finding the B and A matrix. Where for A matrix, it is summation of Q, reduced stiffness matrix, and the thickness of each lamina. So you have to, the thickness will be given to you, the Q stiffness matrix will be given to you. So for each lamina you have to multiply the stiffness matrix to the thickness and then do summation of all the laminas. With that you will find the D matrix. Similarly, equations of A and B matrix is given. That also depends on the ZK minus 1. For D matrix, it is ZK square minus ZK minus 1 square. So you take the position of that according to the thickness of each lamina, then do the square minus them and multiply that value to the reduced stiffness matrix. That will be for one lamina. So here you can see that it is 0 plus minus 45 and 90. So there are 4 and symmetric means 8. So you will get 8 different values even though they will be symmetric. So you can multiply with 2 from one lamina, and according to that you do the summation, you will get the final D matrix, A matrix and B matrix. Did you understand what I meant?
yes, ma'am, but I am unable to do the calculation part. That can you do some sample A matrix? How to find sample
In previous
by taking some.
few sample problems, I have actually showed the calculation of finding ABD matrices. Okay, I will try to find right now. If I can. Here in the screen, can you see? Here there is a calculation of finding an A matrix. Okay, I will show you.
Okay.
Here you can see this is the equation to find the A matrix, that is summation of the reduced stiffness matrix ZK and ZK minus 1, which will be the thickness of each lamina. So here it is the stiffness, reduced stiffness matrix, Q matrix is given, and they talked about 0 and 90 symmetric. So there are 4 laminas, 2 0 and 2 90s. For a 0 degree, this reduced stiffness matrix is for 0 degree, and for 90 only the E11 and E22 will be reversed. So from this, or you can multiply it with the transforming matrix, you will get the reduced stiffness matrix of 90 degree. Now according to this equation, you can see it will you need the reduced matrix and the thickness, that is zk minus zk1, it is position, but here square and cube is not there, so it will be equal to the thickness. So here they took 2 because it is symmetric, so 2 times they have done for one, this is the q matrix for 0 degree. Now 2 times 0 degree q matrix into 0.1 which they have given the laminar thickness, and they converted the units according to that, plus again 2 times because it is symmetric for 90 degree, this is the q matrix for the 90 degree into the thickness, and again they converted the unit accordingly, and this is how they got the A matrix. Okay. Similarly, you have to do for B and D matrix. Am I able to
Okay, ma'am.
explain how to?
Yes, ma'am. Ma'am, but in examination, it will be hard to do all this in the time constraint.
The exam they will give questions that will be easier to solve, and that will be, they will consider the time and how, which will be better, like easier for you to solve within those that time. So don't worry about it. They will take some values which will be easier for you to solve, and according to that. So they will form the question paper considering the time limit only.
Ma'am, can you explain this? When first we will calculate, in most of the cases, we will calculate the strains and then we will calculate the strains according to the material axis. So, while calculating strains according to material axis, why will we take that shear, shear strain as half tau 1 by 2, 1 tau 1 2 divided by 2?
That is how the
But in
equation is. That sir taught in class. For those equations only, they have to take 1 by 2. So you have to remember where you have to take the shear as 1 by 2 and not.
okay, ma'am.
Any other doubts? Rohit, do you have any doubts?
No, ma'am. Like I have not gone through the lectures. I will go first. I go through the lectures and complete your assignments.
End the session here. Thank you.
Thank you. Thank you, ma'am.
Thank you, ma'am.